Hello everyone and welcome to Dr.RAJESH'S BIOGENESIS. You might have looking at the images. Some of the images might look very beautiful to you and some images may be disturbing for some of you. What is that image? Maybe some of them might have understood. But I am going to discuss one of the most beautiful and interesting topics of chemistry, particularly symmetry, and that particular topic is a plane of symmetry, or we can also call it as a reflection symmetry. There are three basic symmetry elements. One is called as a axis, second one is a plane, and third one is a point. I am just taking one of the three symmetry elements, and that is the plane of symmetry. A plane of symmetry is purely imaginary symmetry element that can bisect the given entity into symmetrical halves, where one half is the mirror image of the another half. So to represent this symmetry element called as plane, I am taking three Cartesian coordinates or the spatial coordinates x, y and z. I consider two of these coordinates to generate one particular plane. In the first case it is a sigma xy plane. This is how the sigma xy plane is present. In the second case this is a sigma xz plane, and in the third case this is a sigma yz plane. What exactly is happening after passing these planes? I have represented the operations. In the first case, where it is a sigma xy plane, the above half will be reflected into below half. It is passing through x and y, therefore x and y remain in their position. From whichever coordinate or from whichever atom the plane passed through, those coordinates or those atoms will not exchange their position. Instead, the other atoms will exchange their position. And how does the exchange happen? You can check. When I pass sigma xy, x and y will remain, but z will be reflected into the opposite coordinate, or minus z will be reflected into the opposite coordinate. So plus z and minus z will reflect into one another. The operation is through sigma xy, above half will be reflected into below half. So they reflect into one another. Now let us check about sigma xz. When I am passing a sigma xz, the right half will be reflected into left and left into right. So right and left halves will be exchanged into one another. It is passing through x and z, therefore x and z remain, but plus y and minus y will exchange. So plus will come into minus coordinate, minus will come into plus coordinate. And finally, when I am passing a sigma yz plane, that y and z will remain in their position, but x, which was pointing towards you, will be reflected into minus x, and minus x will come towards you. So the coordinate that get exchanged is x into minus x and minus x into x. So this is how the reflection symmetry will proceed. Even if I choose any chemical entity such as molecule, and if I try to operate the reflection symmetry, one half will be reflected into another, then we say the molecule has some symmetry. When one half is not reflected into another, we say the molecule is unsymmetric with respect to plane. This is to one level. We have understood what exactly is a plane and how many planes can be passed. We can pass n number of planes, but with respect to coordinates I have shown three different planes. Now there is a concept which is always fascinating the people, saying that is beauty related to symmetry. Because we see that most of the constructions like Taj Mahal, Lotus Temple, Charminar, or many temples, mosques, churches, all these constructions or any architectural constructions you can check, they are constructed with a perfect symmetry, where just by a look you can say that one half is looking like a mirror image of the another. That is the first perception that we get. Even if there is a non-chemistry person or a non-architectural person, once they look at a particular construction, they try to analyze that one half could be a mirror image of the another and it is looking symmetrical, therefore it is looking beautiful. So without their perception they have a symmetry element in their thoughts. I have just put some images here. Hope you are getting what are these images. The first one is a Taj Mahal. If I try to pass an imaginary plane through Taj Mahal, you can check that one half is a mirror image of the another half. So they have constructed it with a great symmetry. We call it as a mirror symmetry or a plane symmetry. Those who cannot understand plane, they simply call it as a mirror. But plane and mirror are different. For our concept, plane and mirror are different. Plane is imaginary, mirror is a real one. Now the beauty to Taj Mahal could be due to this perfect symmetry. Now let's come to an insect. Maybe you might have got it. It is a cockroach. This cockroach from outside, it looks perfectly symmetric, where one half is a mirror image of the another half. But if I ask how many of you, whoever is watching this, how many of you say that cockroach is very beautiful and I love cockroaches? Maybe if you are a zoologist, only then you may say that I love a cockroach, or some of you may love. But most of you will say that a very look at a cockroach is disgusting for us. Some of you may say. But with a symmetry point of view, we have to say that cockroach looks very beautiful because it is symmetrically constructed from outside. Let me take a logo. This is a logo related to Mercedes. Try to pass a plane. There are many planes, but just try to pass one plane. When I am trying to pass one plane, the one half is looking exactly a mirror image of the another half. So most of the logos are also constructed in such a way that it looks symmetrical. But can I relate symmetry to beauty? That is always a fascinating question, and there had been plenty of research carried out to relate beauty with symmetry. There are plenty of research articles that even I have studied. I'll just one of the research studies I'll let you know. What scientists have done is, whether beauty is related to symmetry or not to check, they have taken a few images of the most beautiful women of the world. Once they have taken these images, then they try to bisect or cut the images. They are just cutting the images into halves. If this is one half, this is the another half. Let me take this as a right half of the image, left half of the image. Once I have bisected it, or once I have cut the image, then what you do is you generate the other half by a mirror. Just use a mirror image and generate the other half. Likewise, even for the left half, you generate a mirror image. Now once the mirror images are generated for these halves, if the original image is perfectly symmetric, where one half is a mirror image of the other, then if I take one half, I generate the mirror image, I take the another half and I generate the mirror image, all the three images must look the same. They must be identical. They must look exactly the same. Okay, let it off. But what scientists have found surprisingly, almost 90 or more than 90% of the times, I cannot say 100, but above 95% of the times, the right half is not exactly a mirror image of the left half. Either there will be a change in the eye, in the nose, or in the lips, but definitely there will be some change almost for 95, or I can also call it as a 99% of the times. One half is not exactly a mirror image of the another half. So the beauty is not just due to a perfect symmetry, because 99% of the times when one half is not matching with the another half, but still I can say that this particular person or this particular woman or a man is looking beautiful or handsome, it may not due to the symmetry. After doing this small experiment, they have concluded that beauty need not be directly related to symmetry. Beauty is something which is related to perception. How you perceive one particular thing, based on that one particular thing may look beautiful to you, but it need not be a perfect symmetry in it. Okay, so these are some interesting facts, and also I'll tell you, you just go through some logos. Let it be a firm, let it be an organization, transport industry, many industries, you just go through their logos. They try to maintain some symmetry in it. And as an interesting assignment, you can take all the logos, you try to work out what are the different symmetry elements that are present in it, not just the plane, but whether it rotational axis is present, how many of them are there, whether plane is present, what are the different types of planes, whether inversion is present or improper axis is present, and finally you try to work out the point group of all such logos. That will be very interesting. Thank you.